Hello everybody, I'm Anthony. AZVR Mechanical University teacher. Lesson 5. Force distribution in sling rigging. How load weight is shared between the sling legs. Same load, different geometry, different sling tension. Basic idea: under the same load, sling tension is not determined by load weight alone. It also depends on 1. Sling angles, 2. Rigging geometry, 3. Number of sling legs, 4. Load balance. The load may stay the same, but the sling force can change. In rigging, many people first look only at the load weight, but this is not enough. The same load can create a different force in the sling legs when the sling angles or rigging geometry changes. This is why rigging safety depends not only on load weight, but also on force distribution. 2 legs rigging. For balance, 2-leg sling system. Here, the total load, here is W, is shared by 2 slings. However, each sling does not simple carry half of the load in all situations. The actual sling tensions depends on the sling angle. Here is the sling angle, here is theta. Smaller theta, smaller sling angles, high tension equals load sharing does not always mean the lower sling tension. In a 2 sling angle system, it is easy to assume that each sling leg simple carries the half of the load. However, this is only true for the vertical load component in the balance system. Each sling force acts along the sling directions. As the sling angles become smaller from theta, from getting smaller, for example, from 60 degrees getting to the 15 degrees getting smaller, the tension in each sling leg becomes large. Why sling angles matters? When the sling angles decrease, the vertical component of each sling force becomes smaller. To support the same load means W, the total sling tensions must be decreased, because theta is decreased, tension is decreased. Theta getting small, tension getting large. Simple explanations. At the large angles, for example here 60 degrees, 40 degrees, 30 degrees, each sling leg is supposed to load more efficiently. At the small angles, each sling leg must pull hard to provide the same vertical lifting support. A smaller angles can hide a big overload. Here, Compare 60 degree, 45 degree, 30 degree. 30 degree is smaller. Compare is smaller angles. Can hide a big overload. To sum up, 60 degree here, shift. 45 degree angles, higher tension. Arrows is getting thinner. 30 degrees, much higher tensions. I use arrows, is very thick. The carrier or hoist lifting upward, but the sling force acts along the sling directions. With the sling is more horizontal. 60 degree, 45 degree, 30 degree, more horizontal. Less of a sling force is used for lifting. Therefore, the sling tension must be increased. Compare 60 degree, 45 degree, tension is must increased. Use the arrows, here is arrows, on each sling leg. Make the arrow thinner as the angles become smaller. Here, thin, getting thinner. More thinner because of degrees. Simple calculation example. Assume the load weight is W equals 1,000 pounds. For the balance, two leg slings, T equals W diverse 2 times sin theta, where T tensions is each sling leg. W total load weight. Z sling angles measured from horizontal. Here, horizontal different degree, 60 degrees, 45 degrees, 30 degrees. Example results. At the 60 degree, T equals 1,000 diverse 2 times sin 60 degree equals about 577 pounds. At the 45 degree, tension equals 1,000 diverse 2 times sin 45 degrees equals about 707 pounds. Here, this situation. At a smaller degree, here is 30 degrees. T equals to the 1,000 pounds diverse 2 times sin 30 degrees equals exactly 1,000 pounds. To sum up, with the angles drops, the sling tensions rise. This example shows why sling angles is critical. With the same 100,000 pounds load, the tension in each sling leg changed from 577 pounds at 60 degree and 30 degrees tension equals to 1,000 pounds. The load does not change. Load always 1,000 pounds. But the sling force according to the angles decreased. Angles decreased. Tension increased. Safety message. Never judge rigging safety by load weight alone. Always check load weight. 2. Sling angles. 3. Sling capacity. 4. Number of the sling legs. 5. Load balance. 6. Manufacturer's rating chart always give you. Manufacturer give you a rating chart. Rigging safety depends on the geometry, not just load weight. So I need to mention that before lifting, workers must check the sling angles and compare the expected sling tension with the working load limit. A sling may look strong enough based on the load weight alone, but the actual tensions may be much higher because of the poor rigging geometry. Key takeaway. The same load can create different sling tensions. Different sling angles create different force distribution. A smaller sling angles can create a heading overload. Same load, different geometry, different sling tensions. The main lesson is simply but very important. In rigging, geometry changes the force. A safe rigging must understand how sling angles affect the tensions. This is why proper angles selection is the basic safety requirement. Here is the AZVR mechanical universe. Thank you for watching. See you next time.